Today I would like to talk to you about the IDE editor that came with the basic stamp Bobot kit. What you have here, if you've ever used Eclipse, NetBeans, Visual Studios, or any sort of other IDE for programming, so come as no shock in how this works. It's pretty basic in terms of your menu commands and what you can do with it. What you would have here on the side is your the location of your what folder you're currently in. Right now we're working in the C Bobot directory. Right below it would be all the files you would happen to have in there. This allows you to kind of open up them pretty quickly if you have an organized index to grab pieces of code you've tested out elsewhere and thought perhaps you'd like to add in your program. Here is the main window where you would type out your code. This is your syntax, this is where it highlights, you can correct stuff and make pretty lengthy and complex code. Now, to start off with this, you need to know what type of Bobot board you have, or chip, I guess. At the top here, you'll see an array of colored icons. These icons would correspond with what your board is. Your book would also explain to you what type of board you have. I happen to have a BS2 model. Now, when you click on this, this adds basically it's kind of includes for C++ headers or C# or VB. It explains to it what sort of output this thing should be compiling to. If you happen to choose the wrong one, send that information over to your Bobot, it won't get read. The commands won't be interpreted right. Now next, you want to look at these commands up here. Up here is where you would tell it what language version you're using. This helps with syntax highlighting, autocorrect it has, the general fun stuff like that. So with this one, I am using 2.5. Again, it adds an extra little includes, and off you go. Alright, let's see what we can do with this. Before we start messing with any of the hardware, what we're going to do is kind of see how the commands work. Now, you'd also want to make sure your Bobot has batteries in it, plugged in, and also is connected to your USB port. First thing we're going to do is, look at that, it auto update or auto uppercases. I'm going to write debug hello world. What this is going to do is send this to your debug terminal. Now this won't go into your Bobot kit, or it won't go into your Bobot chip at all, so it's not written there, it's just sent to the terminal. What you want to have, then we're going to have an end at the bottom of that. Yeah, it's always nice to have your program end. When we run this, when we switch our Bobot to level, or to switch 1, when we run this, it's going to output just that text to the terminal. Nothing else is going to happen with the kit, nothing is going to turn on, no voltage triggers, it's just going to open that to the terminal. At the top here, with the little run icon, click that. Oh, what? There we go. See, hello world shows up in the terminal. Jolly good. I'm going to close that. And we're going to add a little extra bit to that. CR. That's going to create a new line. So in the terminal, if we happen to have multiple lines of text, let's not have them run together. Let's put them on one line for easy readability. Next, we're going to add a counter, because we're going to look at a small loop. Something easily offered as counter. We explain it's a variable, and the type is going to be nib. That is nibble. Different than, say, a word. I believe a nibble is 4 bytes, and a word is 8. I have to double check that, but I know nib is a smaller option than word. I'm going to initialize our counter. Then we're going to add a do while, essentially a do while loop. Type in do loop until counter is greater than 3. Side here, we have counter is going to get itself +1, so a basic increment. And our debug is going to put out a decimal counter and new line. But below that, we're going to see when it's done. I'm going to save this as, let's go with hello world, and then run it. Oh, look at that. Prints our hello world initially at the top here. Goes through, increments our variable, and then prints done. Pretty cool, isn't it?